Hi everybody, how are you? I hope you guys are doing fine out there. I just want to go over through this video the worksheet I asked you guys to do last class. The first one is temperature and formation of our solar system. The second one is sun size. The first one, based on we have learned in class, I think it should be pretty straightforward. You can see two categories of the planets in the solar system. The first four belong to terrestrial planets. The last four belongs to the Jovian planets. And you guys can just take a look at the solution I posted on the blackboard. Maybe if you have questions, you can post questions through the discussion board, and I will try to answer the questions on that. The second one I want to spend a little bit more time talking about, because this is one of the most important topic actually we discuss in astronomy. There are two things actually emphasized in this worksheet. The first thing is, when we compare two objects in the universe, okay, it is whether it is Earth, Moon, or Sun, or even the distance between the objects, because if we want to compare two things, we usually use ratios to compare them, as you can see here. And I mentioned this, at the very beginning of the semester. We use ratio to compare two objects. So for instance here, for the Earth's diameter is 12,756 kilometers, and for Moon's diameter is 3,476 kilometers. If you do the ratio, we don't do subtraction, we do ratio, which means division. So it's approximate 4. That tells us the Earth is approximately 4 times wider than the Moon. And that's why you can see here on the first page of this tutorial exercise, you can see that you can draw 4 moons inside one Earth. The second thing this tutorial exercise actually emphasizes on is that, because all the objects we talk about in the universe, they are very far away from us, and also they are pretty big in size. So what we can do is we usually use some kind of scale model. We use like the things we are familiar with, such as basketball, baseball, soccer ball, ping pong ball, pea, or other familiar objects, to make an accurate model, and then so we can understand their relationship much better. The first page, actually you don't have to do number 2, so I cross out number 2 so you don't have to worry about it. And I want you to go to next page. If you look at part 2 here, okay, so for part 2, especially question number 4, there are several objects listed here under question number 4, and I checked online for the particular sizes for each object. So what you can do is you can compare the ratio between the two objects, and then also you can compare the ratio between the two astronomical objects. If they are approximately the same, that means we can use that scale model to model the objects in the universe. So for number 4 question here, okay, can any combinations of the following items be used to make an accurate scale model of Earth and the Sun? So we know that for Earth and Sun, actually before question number 4, you can see we use the diameter of the Sun divided by the diameter of the Earth. We can find out the Sun is about 110 times bigger than Earth. Then if I use the soccer ball, okay, and then divide it by the sand, and then you can approximately find out it's about 100. So 100 is close enough to 110, so that's why we can use a grain of sand and a soccer ball to model the relationship between the Earth and Sun. So the rest of the questions actually I explained through the solutions I posted on the blackboard. Again, if you have any questions, please post the question on the discussion board, and then we can if I have I found a common question, I will answer question through the discussion board. If I found a lot of students having difficulty answer some particular questions, then I will make another video and try to explain it. All right.